So thanks a lot for joining me today. I'll try to be respectful of your time and finish right on time, and hopefully leave some time at the end for some Q&A too. I'm Jeff Reeser, my colleague Kay Tate, and we'll be taking you through some examples, industry examples of how companies are using AI, machine learning, distance learning, or deep learning as well, in an HPC environment. So I want to start out by first setting the stage so that we're all on the same page, and throw out a few definitions and how the market is doing in this space as well. And so I wanted to start with a few factoids that I put together around the HPC market. And the first one is probably the most significant one for this whole presentation, is that companies are realizing some incredible return on investments. And this is from Hyperion Research. They did some research on this. They said for every dollar invested in HPC, they had on average $463 return on investment, which is incredibly huge. And if they're looking at cost savings as well, they had a $44 average profit for that per dollar invested. So that's a strong statement. And if we look at the HPC revenue worldwide, and this incorporates both hardware and software and services, you're looking at $19.5 billion by 2022, which is also pretty significant. And when you look at the kinds of applications, the kinds of workloads that are being run in this space, primarily it's big data, incorporating volumes and volumes of data, especially with the advent of IoT and all of the sensors that are out there, gathering all the data, collecting it, storing it, and companies looking at that through their AI applications and trying to get out some effective insights from all of that data. So big data combined with a high-performance computing environment, they're starting to create some new solutions as well. And so we look at the most popular workloads that are out there today are primarily AI. Machine learning is coming on strong right behind that. Deep learning is primarily in the research facilities today because not enough data is out there yet for the real deep learning to actually occur. But it's growing quite a bit. And HPDA is high performance data analytics. So with all of the analytics applications that are out there today, HPDA is another hot area. And something I did not list on here is something called HPAI, which is high performance AI. And that's kind of a combination. They're looking at AI applications today, containerizing those applications and putting them into a highly scalable environment with maybe a combination of on-premise CPUs and GPUs. So you'll see some references to HPAI as well here. There's a top 500 report on supercomputer sites around the world. The report comes out twice a year in June and in November. It's put out by the top 500 organization. And in there, they list all of the supercomputers in the world in the top 500 and what operating systems they're running and the kinds of work that they're doing and some of the hardware specifications as well. When I did some quick analysis of that report, and SUSE Linux is running on nearly half, 24 of the top 50, which is a pretty strong statement to make as well. When you look at some of the other commercially available Linuxes out there, what's being used. And when you look at the top 100 of those, SUSE actually dominates the share there. You see more and more CentOS and free Linux as you get in the smaller size supercomputers. You can see how, that's their sweet spot for that, just getting started in the Linux space on the smaller sizes. But overall, I took a look at the commercial share of OSs across the entire top 500 list, and that represents 111 supercomputers in the whole list. So these are supercomputer areas that are actually paying for support, paying for the subscription for the commercial OS. And SUSE dominates there as well with 59%, which is pretty compelling. To me at least. I saw Red Hat at 22%. A Bull from Atos is 15%, and there are a few Ubuntus out there. So we look at the whole landscape of what's going on in the supercomputer space and what's going on in the HPC space as well. We're seeing more and more adoption of HPC even in-house across industries within various companies that if they can afford to bring HPC environments in-house, it's becoming a much more cost-effective way of doing business, especially with their new parallel computing type applications, AI and ML, being enabled to run those applications in-house is very good for them instead of having to pay for time at some research facility somewhere. So I wanted to set the stage again. SUSE, while we don't have an AI ML solution per se, we do make those solutions and those workloads run much better. We make them easier to develop because we offer some frameworks that are available for Linux. We make them faster because of our HPC platform and the parallel computing enablement that we have, and then we make them more manageable. So that's where we fit into the whole picture today. We are doing some work with some key partners of ours that we'll talk about in a minute too. But that's where we fit today. But we're seeing businesses around the world that are recognizing that first they need HPC as the platform base to help run and manage their workloads. But it's really vital to have that start and be able to adopt it and understand it and maybe even rewrite their applications to make sure they're taking advantage of that parallel computing environment. And our HPC product comes along with what we call an HPC module. Within that module, we have several third-party packages. If you're familiar with that space, there are some popular packages like there's something called Slurm, which does workload management. There's something called Ganglia, which does workload monitoring, performance monitoring. So there's a whole collection of computational libraries that we include as well. So it's become very popular. Now, every package that we include within the HPC module, SUSE supports, which is another big step in it's a great leap in the right direction for people that are just getting started in HPC and starting to adopt it in their environment. Another a big differentiator that we have is that everything that we have, the operating system, these packages that I just mentioned in the module, they support two architectures, ARM64 and x86-64. So it's very important. There's kind of this advent of ARM-based supercomputers out there that we're working with HPE and Cray and a few others, and so it's coming on strong as a cost-effective way to really adopt HPC. And we have many IHVs, ISVs, and cloud providers out there that we partner with. I'm not going to really go into much depth on IHVs, but there are people like Fujitsu that are out in the showcase there, Lenovo as well, that are doing some great work in the AI and ML area, and we're a part of those discussions with them. I will talk about Microsoft Azure a little bit and AWS for cloud. So we are actively investing in this HPC area, which is and we've recently repriced our product as well. So we have so much lower cost pricing. We also lifted some restrictions on when you can actually implement and use HPC. So we lowered that from needing to have 64 compute nodes down to 4. So for the smaller shops, it becomes pretty important to be able to do that and save some money. So I wanted to also brush through some HPC-related projects that we're involved in too. There's SUSE Package Hub, so we're working with a number of vendors to make sure that they're tested and able to run on the SUSE HPC base on that platform. So we have some that are out there today, like this one out here at the end is called Robinhood, which is a policy manager. That's available on Package Hub. We're also working with TensorFlow and Singularity for container management that should be out in Package Hub very soon. We're also doing a lot of work with Kubernetes, and HPC environments and containers are pretty much work hand in hand. Give me some water, please. And then we have other communities that we're involved in as well. OpenACC involves a lot of accelerators and derivatives that we use in this environment. So OpenACC, OpenHPC is another community that we work hand in hand with as well. Software-defined storage is coming on strong, even for the HPC environment, and we're finding that it can be used pretty heavily and pretty popular for archival, backup. The speed might not quite be there for high-speed storage involved there, but thanks, Joe. But at least today, for archival and backup, it's coming on strong as an option. I did mention ARM64 gaining more popularity. So we have this initiative in the UK called Catalyst, which is a joint effort between SUSE, ARM, HPE, and also Marvell or Cavium. And we're also implementing supercomputers that are ARM-based in several universities in the UK. University of Bristol, Leicester, Exeter, University of Bath, Cardiff. So this is really key here. So they are adopting it, it's ARM-based, and we hope to expand that into mainland Europe as well. HPC in the cloud, this involves some work with Azure and also with AWS, and it's really making images of our OS and of our HPC module as well, and making them available for the cloud. We were the first instance of an HPC operating system for Azure, and that became available in the Azure marketplace, and we hope to expand on that program and maybe make some of the other third-party tools available too. And finally, our HPC module. So here's a list of some of the packages that we include in the module. We have some message passing interface functions. We have some file system functionality for the HPC environment. We have workload management and monitoring as well. Don't bother trying to read all this. We do have a reference architecture for HPC. So I just wanted to show we have the four basic areas of an HPC architecture. We have the clustering involved for the compute and head nodes. We have the interfaces involved, like MPI, message passing interface there. We have the tools involved, and many of these tools that I have listed over here for management and monitoring are available in our HPC module. And we have the storage involved, the various file systems that you might need in a parallel environment. Okay, I'll let this build out. This is the whole spectrum of AI type solutions, starting with the rather simple AI examples like Google Maps, gameplay, machine learning, gets a little more in-depth, driverless vehicles, etc. And then we get into neural networks and deep learning. And I mentioned HPAI in the beginning. This is actually a slide from one of our big customers in Germany called LRZ, the Leibniz Research Institute or Supercomputing Center. And what they talk about here is that this is their SuperMUC next generation computer. It's Lenovo based, it runs Intel, and it runs SUSE. And what they're doing is containerizing all of their AI workloads to allow them to run very well in this environment. So we see AI and HPC popping up across many different industries. I'm going to pick out 5 of them for this session, but you can see in manufacturing, banking, healthcare, automotive, security, retail, energy. All of these have many different examples of how machine learning and AI are being used today, and many of these are starting to build HPC environments in-house as well, which is a much more cost-effective solution for them once they get it in place. Okay. Now that we've set the stage, let's talk about the different communities involved. So I mentioned that we work with the OpenHPC, we work with OpenACC as well. We just became a new member of OpenACC back in November. And hope to be a strong contributing member of that community too. Linaro is primarily ARM, OpenStack, Ceph, and Lustre as well. And along with that, we have a number of key capabilities that we've talked about too. I mentioned some of these when I talked about the HPC module, and then there are others that will be available through Partner Hub or Package Hub as well. Things like TensorFlow, Singularity for containers, and Robinhood. And there will be more. And then we have a number of ISVs. Like I said, I'm not covering the IHVs so much here, but if you get a chance to talk to people like Fujitsu over there, they've been really strong in the AI area and can talk at length. This is beyond what they're doing with business critical Linux. They're doing some great work there. So I'm going to let Kay talk about the ISVs.
Thank you, Jeff. This is a really exciting space for the kinds of things that are going on. They're really revolutionary, things that you wouldn't necessarily think of as the ISVs start to apply. You recognize a lot of these ISVs, MathWorks, Altair, ANSYS. A lot of them have been around for quite a long time. And almost all of them are now starting to apply a bit of ML, AI technology into the offerings that they're making for their customers. It's worth their time to do this because even as of 2016, half of the top 500 supercomputers were deployed in industrial settings as opposed to the research settings, the labs, and that kind of thing. So this is really a rapidly advancing area. One of the things that I kind of wanted to talk about as I was thinking about a SUSECON talk was, you know, hey, everybody can do this. Well, it's still a little bit early. It's a good time to start picking your projects. And if you have a, favorite ISV that you work with in this list, talk to them about it. You want to make sure that you're going to get the results that you're looking for and that you actually know what you want to look for as you start to apply some of the machine learning to it. So we're at the beginning, but it's the perfect time to get in right now. And I'm going to go over several of these and what they're doing, and in particular how some of their high-performance computing projects are starting to contribute to our daily lives. As Jeff showed in his segments, this really is something that's starting to impact us on a daily basis and in a positive way. The other thing that we find is that as more and more high-performance computing gets applied in these different areas by these different vendors, we're finding that there's actually a virtuous cycle here where the machine learning running on HPC is able to do more with big data sets. Jeff talked about the IoT information coming in. There are all kinds of new big data sets that are starting to have the high-performance computing applied to them so that you can get data reduction, you can start to do this machine learning on it, and so we end up with this virtuous cycle. So that's pretty cool stuff. So I'll turn it back to Jeff.
Okay, so we're going to start going through some examples now. The first one is consumer goods, and this particular example is about appliance design, or as my mother calls it, an icebox. Very technical. So they're looking at goals of reducing the time to develop the ovens, the washing machines, the fridge, whatever they need. And simulation is a big part of appliance design. What they want to be able to do is simulate and test lots of different variations of the designs before they go ahead and build a physical prototype. Because building a physical prototype costs a lot more money. So they can really do a lot of this testing beforehand and really know what they're up against. And they have a number of challenges too. So they're trying to find this sweet spot in their designs. They also have to deal with a lot of very sometimes complex regulations and safety procedures and cost requirements as well. So they're up against that. And in this particular case, they're looking to reduce customer returns and associated revenue loss that might be incurred as well. If you look at HPC and AI examples in this space, it's all what's running the simulations and the designs. The prototypes are used for the validation. They're not used for the actual development of the physical prototypes. And they want to be able to save money, and they can do that because the packaging and the product designs are much more innovative, and they can substantially reduce the damage caused by shipping. And there's a little bit more that they're doing in the consumer goods space: affinity marketing, buyer behaviors, figuring out how to target marketing to specific buyers at certain times. They're using AI and ML in their smart inventories, supply chain management, and also cyber fraud is a big use case for what they're doing in the space. Very important in the retail space. Okay. And just wanted, so for each of these examples, we're going to point to the ISVs that are associated with doing a lot of these, or working in a lot of these use scenarios as well.
And so the first thing we'll do on these slides is sort of talk about what they're doing in that same space, and then I'll just give you a kind of a brief overview of the ISVs so you can actually see most of these ISVs have a much greater breadth than just the slivers that we're showing you today. So if you are in a space, if you're using any of these ISV products, ask them about what they're doing with their big data and with their machine learning, because if you're in a different domain of expertise, they may still have something that's really interesting for you. So as we look at the consumer goods, we talked a little bit about, Jeff mentioned the virtual design spaces and being able to do complex simulations and do them faster because you're on HPC. The other thing that is fundamentally different and has been growing over the last 10, 15, 20 years actually on supercomputers is the ability to simulate more and more systems together. One of the things that ANSYS does that's really extraordinary is to be able to do what they call multi-physics. So you can use their fluid flow application parts and tie those into their structural application parts. So if you're looking at something like a washing machine and you want to mitigate the noise, you can work with their noise simulations. You can work with the overall product, and instead of just doing a vector to see how the tub is going to shift in a particular way, you can simulate the whole system. And it's really been an amazing step forward for a lot of application providers. It's really been exciting stuff. So, as we said, try this. ANSYS does structural mechanics of all different kinds. And they can do multiple simulations. As Jeff said, saves you a lot of money. You don't have to build prototypes. And then you can put the multiple systems together. And what's going to be more interesting to put different kinds of systems together than an electric sports car, right? A super sports car. You're talking about all kinds of things of, battery weight and simulations, aerodynamics, how that thing is going to go down the road. It's amazing things that you can do. And so we may talk about being on the early edge of machine learning, but you can apply machine learning to a lot of different kinds of things and come together with something that is it's a game changer. It's a different way of thinking about the problem altogether.
Yeah, that was good, Kay. And also I want to mention too that ANSYS is a close partner of ours, a close ISV, and they're also the most popular HPC application out there in the world. So they've got a lot of notoriety for that. Scene 2, let's go to energy. I talk about energy and utilities, specifically sustainable energy. So innovation is always key here. I want to be able to increase the responsiveness with the product supply and demand. And priorities keep changing among customers in society on what kinds of energy might be more amenable to them. And they're, again, dealing with a lot of regulations for health, safety, environment that they have to deal with too. From an HPC and AI perspective, again, there's a common theme here. They want to do simulations, they want to do modeling, help reduce the cost of future operations, and they want to do this to avoid building physical prototypes maybe a bit prematurely, because they can run the simulations over and over again with many different variables, many different parameters. And they're using AI and ML quite a bit to really govern the way they produce, transmit, and consume energy. Very important here. And if you look at smart grids across the countries, they want that to be able to be powered by AI ML, which will help guide them in providing more cost-effective energy and understanding how to best allocate those energy resources. And I thought this was pretty interesting too. Hyperloop, another customer of ours, what they're doing today, they're doing some tests now. They have these tube systems that where they can push through passengers and vehicles at speeds up to 700 miles an hour. And they use magnetic accelerators to do that. And it's a really interesting use case. What they're doing too, they're simulating this. They're making the simulations available to many different researchers across the country. And so they're switching around the parameters and the variables, and they're very keen on producing a very safe environment. They're looking at what happens when earthquakes occur or power outages occur or fluctuations in passenger busyness within the Hyperloop system. And in effect, the design needs to be very safe, very reliable, very affordable. So HPC simulations are really key to what they're trying to do in the Hyperloop space. And I thought this was a super interesting use case as well. It's called tidal energy. And unless there's some problem with the moon, if the moon explodes, we're always going to have tides. So it's really key, and they're looking at these tidal turbines, and with this membrane that kind of swims within the current, and it produces energy as well. And it's very efficient. It's even more efficient than solar energy or wind energy. And there's no pollution, no waste, very little noise except for the tides, no harm to wildlife, and it's really it's the future energy. They're looking at simulations and how to get the best energy out of this kind of a new resource. And ISVs.
And talk about something that's difficult to prototype at scale. The impact of the learning and the high-performance computing and getting into the intelligence to be able to work with these things and look for the optimizations really opens the door to being able to do things that we just couldn't do in a reasonable way, just with engineering itself. So talking about the energy and utilities specifically, one of the things that's a little larger than what you would typically think of is that we are now able to simulate energy plants, the whole physical plant. And Dassault and ANSYS have been participating in these kinds of things. Not only are we looking at very specific biomass reactors themselves, how are we going to make these things more efficient? Water, wind, solar cells, how do we make these things more efficient? How do we store the energy better and that kind of thing? But we can put those together in entire plants. And one of the things that people are starting to do in looking at these entire plant simulations is being able to look at how the systems interact, how we make sure that they're really safe, and they're even using these things to start to train people before the plant is completed. So it really gives you a great advance in being able to work with these things and get started on a very long power plant build cycle, which has been difficult always. And then ANSYS also gives us this simulation capability to work with the individual pieces, to trade out individual pieces, those kinds of things, to put together the whole plant. Dassault, as we said, has been a key player in putting these kinds of things together. They do a lot of modeling with a lot of collaboration. They also have product lines for working with consumer markets and doing modeling along those lines. So it's a little different from what you would think of as, an engineering and a graphics kind of company as they've been branching out. They have a data management line, which is also extremely helpful and again feeds into this virtuous cycle that we talked about, and they even actually have planet modeling. So they've really gone big scale on that one. It gives you a little bit of an idea of some of the breadth and some of the different kinds of machine learning and AI spaces that they're currently applying their technologies to.
Okay. And I think that should it be plant modeling. But although that's pretty cool too.
No. Planet.
Is it really?
Yes.
Wow.
Yes.
That's impressive.
Yes, it
Okay.
is.
And this planet, right?
This planet.
Okay.
One time, no, I didn't know about Venus.
So the third scene I want to cover is automotive. And this is near and dear to my heart because I own a car. You might too. And SUSE is pretty prevalent in the automotive industry. There are a lot of automotive manufacturers that are using SUSE, helping with their designs, their fine-tuning of their engines, et cetera, from McLaren to BMW to you name it, Ford. very popular. And the goals here again, in their designs, in their modeling, in their testing, they need to refine the designs over time. And in some cases, like Formula One racing, they want to be able to change the fine-tuning on demand in a split second. And they can only do that if they have some of these AI, ML kind of techniques running constantly. So the R&D costs can be very high, and so their goal is to really speed up their designs, speed up the quality of their designs as well. And you can see some examples here of how the automotive industry is using HPC in conjunction with AI, ML kind of workloads. They want to be able to provide the best simulations and the best platform for doing that, so they can do that very well with HPC at the base. They also have a lot of data that might be held in the cloud. So if you're driving along and you need some to be aware of what's around you, you might have to go to other sensors, other data to help you figure that out. And so driverless vehicles as well, using all of this data too. So it's a pretty hot area for AI and ML. And I'm trying to speed it up a little bit so we can get through everything.
Yeah. So a couple of the vendors that I'll talk about here are in a very specific area, in the electronics area. We can all pretty well imagine how many different kinds of electronics, gizmos and sensors and IoT, as well as now thinking about some of the automatic driving facilities and that kind of thing, that are all coming together. And our ISVs are recognizing this kind of thing as well. There is an electronic control unit that sits under the dashboard of most cars, and that's kind of the brain of the car. It's where everything comes together. It can help with your fuel injection, it can help with your radio, it can help with your radar. Are you too close to the car in front? A couple of the vendors that are working in this area that are key are the MathWorks. And in fact, I'll show on the next slide, MathWorks has actually developed a virtual ECU that can be tailored to different kinds of chips, so that multiple different kinds of car vendors can work with their same prototyping environment and make great strides on a number of different chips. And then also, where you have the special chips, Synopsys is the leading chip designer from the standpoint of the automotive design and test and that kind of thing. They really look at the next delivery of IoT devices for the next generation and are really known to be cutting edge. I mentioned the universal ECU. Cool stuff.
All right, so let's move on to number 4. It's manufacturing, specifically materials science, materials design. And this is pretty popular in the automotive space, but also in aerospace engineering. And the goal is to build very lightweight materials, very strong and sturdy materials, and materials that can withstand huge temperature swings and extreme temperatures. And they also have a lot of safety and compliance regulations they have to deal with as well, whether it's oceanic, deep space, automotive, aerospace. So they have these challenges ahead of them too. Again, there's also lots of databases that they use too. They mine the databases to figure out what sort of recipes they can use to put together the right chemistry to produce these materials. If you look at how AI/ML is being used in here, a lot of it goes back to the modeling. It goes using algorithms that can predict which compounds, which combinations can produce the most interesting, sturdy, lightweight materials that they can use when they're manufacturing their vehicles or rockets, whatever. And for the manufacturing ISVs, I hand it back to Kay.
On this one, I'll change gears a little bit. These are some of the basic infrastructure vendors that are underlying a large swath of the simulation that's going on. Bright Computing is really an amazing cluster management system. They can make everything come together on a pane of glass. They can help the customers extend to a hybrid cloud in a secure way. They really make your life easier when dealing with those clusters of systems and doing so dynamically. The other one that I'll talk about a little bit is the Univa Grid engine. That is a place where you can specify all the different facilities in the different systems that are in your cluster. And when you need to provision new jobs, you need to spin off new containers, that kind of thing, Univa Grid can help you anchor where those things should go. And between these two, they've got a strong integration between them. They can really make your life very, very manageable. And they can help people who are not interested in becoming big cluster geeks really work with these kinds of things as a very solid underpinning for a lot of different industries. So just a little bit about them. I pretty well covered this. As I said, this can help do your workload placement automatically, and then Bright can help you keep everything running along smoothly and balanced.
Yeah, and also we've worked pretty closely with Bright and Univa at a number of our customer sites. The Tokyo Institute of Technology is a big customer of ours too, and they involved both Bright and Univa for what they were doing as far as infrastructure management. So it was a really good example there of what they can do. The final scene I want to go through is healthcare. So specifically pharmaceuticals, drug research. And the goal again here is to come up with drug discovery very quickly. They want to produce more predictable drug treatments plans. So when a patient walks in, you want that treatment plan to be accurate and have it in hand for the patient before they walk out the door. Also, like many other scenarios here, they wanted to have a consolidated view of all the servers and clusters and instances that they have in the public cloud. So that's kind of more of a generic kind of need that they have, especially in the healthcare industry. And they have a number of challenges. There's many different types of biomedical and healthcare data that they need to deal with and consume, and try to come up with some good insights out of all of that data. And there's a number of companies in the pharmaceuticals area that are looking at determining new and maybe naturally occurring compounds that they can use from other food sources and put them together for some beneficial healthful effects. And you can see some examples here for HPC, AI, and ML, how they can use machine learning to help them predict treatment results and help them match up drug interactions with patients and interact with all of the data that's available for particular patients and for particular drugs. And there's also some initiatives using AI for precision medicine. So they're very targeted, very focused on particular patients, and also using it with other health data applications. And here you go.
So a couple of the ISVs I'll talk about here I'll mention one other thing about Bright, talk about Altair, and talk about SAS. Most people know about SAS, and we are working actively with them. They've got some very interesting new initiatives as well in the HPC space overall and ML. They are, all three of these are actually working with gene-specific diseases and helping to decode the genome further and study it further so that we can address these things better. One of the things that they have several examples of, which are very interesting, has to do with overall groups of patient studies and being able to apply machine learning to see the best outcomes, which are really the best outcomes, which are, you know, perhaps look promising but aren't necessarily the right ones that you would want to apply on a wide scope. One of the things that's interesting about the Bright software, they also have a data science product. And this helps their customers establish one of the Hadoop versions from some of the different vendors in a much easier way, so that it makes your job easier to get started in dealing with some of these very large data sets from a number of clinicians. They have one example that has 10,000 clinicians included. That's a lot of patient data. They have examples where they work with multiple manufacturers in Europe, where there's a benefit to being able to do some local manufacturing. And they can ensure that there is a high quality across all the devices that come out by doing certain kinds of testing, comparing the outputs, and those kinds of things. There's also a really interesting study from Altair about a brain blood flow model that was done in Japan, and it's a general model so that different researchers working on stroke, working on different kinds of brain injuries can apply this model and look at different kinds of blood impacts, lack of blood, and things like that, and do specific studies for what they're working on. So it's kind of like the next thought of open source, but it's for blood-brain studies. So that's kind of cool. So Altair has done a lot of production of codes for a long time, helping programmers, helping them put simulations together. And we've talked about component modeling for vehicles, and they also have increasing amounts of coordination of some of the HPC systems that they're running on as part of helping the programmer jobs and so forth get developed better and more effectively. And SAS, most people have run across SAS somewhere. It's been around for a long time. They do a very wide swath of intelligence processing. And one of the things that has been exciting lately, about 2 weeks ago, I think, they announced a $1 billion investment in machine learning and AI. And the thing that's very interesting about this, I mentioned earlier wanting to be able to say, hey, everybody can do this. And we're not quite there yet. A large component of this is also going to be education, to help people learn how to structure that discussion and apply it to their own domain.
All right. So, our ending here. So I'm just going to conclude a little bit. We looked through 5 different scenarios. You can see specifically within each of these industries what we talked about here. At the bottom, there's a link here. You don't have to copy this down or anything, but there's a link here to a case study booklet that we recently came out with, recently as in this morning. But it's out there, and check it out. So we have some more in-depth examples, SUSE examples of who's using it and how they're using it specifically for AI and ML. You can get the slides later. And we validated some conclusions at the same time. So just to reiterate, while we don't have an AI ML solution today, we do make those solutions better, faster, easier to develop, and more manageable with our HPC platform today. But there's a lot of work going on with our partners related to these workloads. We're related to container management with NVIDIA, Singularity, others as well. Related to HPC in the cloud, HPC bursting in the cloud, which is becoming more and more popular ways of doing things. So there's a lot of work going on in this area. And we talked about a number of ISVs. Like I said, I'm not covering HVs because we'd be here till Friday. But anyway, so with that, I wanted to mention too, I don't know if you've noticed that on every slide in the bottom left corner, there's a little glyph. So if, just for fun, if you wanted to send me the solution to the glyph puzzle that I have embedded throughout this presentation, just send it to me at jeff.research@suse.com. And the first 20 winners, I have these little gift certificates, $5 off for the SUSE store. So happy to give those out too. And if you didn't catch any of the glyphs, you want a copy of the slides to check it out, and also to look more in depth at a lot of the words that I didn't get a chance to really go through. I put the slides out on SlideShare. So slideshare.net/reserj, R-E-S-E-R-J, will get you to the slides, everything that I showed here. So you can download it, take a look at it, and more in depth. If you have any questions at all, feel free to send me a note with your questions as well. And I'll make up the answers. No, I'll get you the right answers. So with that, I know the SUSECON will have all the presentations available shortly, maybe after this week. But for now, at least immediately, you can get them on SlideShare. So with that, thanks a lot for your time. Appreciate it.